the maximum kinetic energy is at the bottom, and the frequency of the light that is shown on there is on the y-axis. Now, frequency, maximum kinetic energy. Okay, somewhere where the maximum kinetic energy is 0, there we still have two values, two frequency values. What can those two frequency values be? The threshold frequencies of the different metals. Okay, because it's where the kinetic energy is 0, we know kinetic energy is given off, there we still have a frequency. It's not like the graph ended there. So this is the initial, the beginning frequency when there's no extra energy for kinetic energy. What is that? The threshold frequency, the minimum frequency needed for electrons to be emitted from the metal. Okay, we see two straight lines, sharp, sharp, sharp. Now they ask there, define the term threshold frequency. Can you see that the definitions they ask is linked to the question? They don't just randomly go any, mini, mini, ask this definition. They give you a clue here. Listen, threshold frequency is somewhere there. Okay. Threshold frequency, are you writing down? Is the minimum frequency required for electrons to be emitted from a metal's surface. Yes. The minimum frequency required. Are you writing, Rafilu? Huh? Oh, yeah. Fancy. All right, next one they say, how does the maximum kinetic energy of N compare to that of M when the light of frequency greater than 10.4 is shown on each of the cathodes? Okay, so there's 10.4, greater than that. Let's say here, okay, here, this is M, this is N. How does the kinetic energy compare? How does N compare with that of M? N is greater than M. You see that? So I went to greater than, I looked at there it crosses the line, there it crosses the line. This one, this one. Which one is bigger? N is bigger. They said, when light of frequency greater than that, there is 10.4, so greater than that is, say, there. So here, if I draw a line here, this will be where it meets M, this will be where it meets N. Graph N, graph M. This one, this one. This one will be bigger than 23.01, this will be smaller than 23. Yes? So it's N. N is greater than M. Now they ask, calculate, for 5 marks, calculate the value of frequency Fx indicated on the graph. Fx, there's Fx. Okay, now, they give me a clue here. They say Fx is on graph M. You don't even look who it is, you put it off. Okay, it's on graph M. So they specifically say consider M. Okay, consider M. Fx here, if the kinetic energy is 23.01. And what else do we know about M? We have its threshold frequency. Please note that there is 10.4 times 10 to the power 14. 23.01 times 10 to the power negative 19. Okay, so start with your info table. 18.3, we have 4M. The threshold frequency is 10.4 times 10 to the power 14. We want Fx, and we have the kinetic energy maximum is 23.01 times 10 to the power of negative 19. Fx is what? That is what they ask. Yes? Okay. Okay, which formula are we going to use?
E equals to
E, yes, work function times kinetic energy.
Why is there? Okay.
Okay, now let's check. Kinetic energy I have. Ooh, I don't have that, I don't have that. I just have frequencies. We can get to it because you can elongate this to get that and that. Yes. Go to your data sheet. Sure. On the data sheet they give you E is equal to that and the work function is equal to that. Okay, now you fill in your values. What is H? Okay, on your marks, get set, go. What's wrong, Bukamuso?
So the F that we're wanting is the with the one with the E. That F.
Yes. Yes. After? HFC. I don't have HFC. Yeah, then? WC. W0? What? Yes. Planck's constant. There. Oi, 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 oi. Yes? Is it easy, Fatima? Do you think Clona didn't come to school because he didn't want 2 science periods?
No, because of life science.
Because of life science mock exam.
After school and
And ours is 3 hours, ne? Our mock exam.
Yeah, well, ours is 3 hours.
No, it's only chemistry.
Yes. And the chemistry test is 150 marks, which is 150 minutes.
I had no say in that whatsoever. Okay. Yes? No? Yes. Shop. What? What no? Do you have these values?
Yes.
Okay. So you know you can type in all of that. Did you type that?
Yes.
And then what are you going to do with this?
Divide.
Okay, so you're going to say that divided by that.
Not swap there.
What do you say, Kena?
King.
Oh, what's Kane?
What is wrong with you? King, come on. What is wrong with you?
And the answer?
Isn't it?
Nothing wrong with you. Well. Alright, now they say there. The experiment is now repeated for cathode M. Okay, so again M. With a light of frequency X, Fx, but with higher intensity. What does intensity do again, Fatima? It's going to increase the number of photons and thus electrons. Okay. Now my question to you, Rafiwe, is if you increase the intensity, do the electrons move faster? Okay, so this is what you should know. I think it's the 4th time I've said it in this chapter. Intensity is just to add more electrons, not... no, it adds more electrons. It doesn't give them more energy. So it's not like you have one electron and it gets more energy. It's that you have now more electrons with the same energy. Okay? So increase the number of photons, meaning same energy, just more.
Yes.
Okay, right.
So it's the same Jacobs, but more coffees.
Yes,
More cups of
yes. Okay, so the energy of each electron is the same. The kinetic energy of each electron is the same. There's just now more electrons. Okay. How will each of the following be affected? Choose from increase, decrease, no effect. The y-intercept on the graph. What was the y-intercept? The threshold frequency. Will that change if you increase intensity? No, nothing will change that.
No effect.
No effect. The number of photoelectrons emitted per unit time? It will increase, because if you increase intensity, you increase the number of photons, increase the number of electrons being emitted. So 18.4.2 increase. 18.4.3, the maximum kinetic energy of the emitted electrons? No effect, because you're not increasing the frequency. If you increase the frequency, then it will increase. So it will be no effect, increase, no effect.
The intensity increases the number of photons, and then the frequency.
Increase the energy of a photon.
A.
And one.
So the frequency is about the speed.
Yes.
And then the intensity is about
The number of. Okay. Then question 17. Now I'm just going to talk through question 17. But you must still make notes. Say question 17 and then you make notes regarding question 17. Say again? No. Change your attitude. It's like now. Change it. Graphs are your friends. Say it. There we go. Graphs gives you a lot of information in a small space.
Like you said, you love the graphs because you don't want to read the whole thing.
Yes, why do I want to read a lot if I can just look at a picture? Okay, now they tell you there that here you get the relationship between kinetic energy and wavelength. Wavelength. I haven't mentioned it once. Okay, in waves, in normal waves, we have F is equal to frequency times lambda. Are you making notes? Question 14. V is the speed of a wave, velocity of a wave. Now, we use this formula when we are busy with sound waves or when you are busy with water waves. Are you busy with sound or water waves? No. We are busy with the electromagnetic spectrum, where this formula changes to C is equal to frequency times lambda. Yes?
Yes.
What is C is the speed of light, 3 times 10 to the power of 8. Yes, that is a constant that you'll find on your dot sheet. So from here, I can rearrange this to get frequency is C over lambda. Just rearrange it. So I put lambda underneath, or you divide by lambda, the wavelength. So we can see that frequency is inversely proportional to lambda. The bigger the wavelength, the smaller the frequency. Smaller the wavelength, bigger the frequency. So if you have big waves, small energy, red light. Big frequency, high frequency, small wavelength, high energy, blue light, UV light, purple light. Okay, right. Then, next thing is we are busy with this chapter. Photoelectric effect. And E you can either write as what's her name? Planck's constant times frequency, or Planck constant times the speed of light over wavelength. That's wavelength there. Let me just write that neatly. Nee man, dit is there. I'm writing down formulas from your data sheet. What? What's wrong? Okay, so can you see that instead of writing this, you can write this that we've used a few times. Instead of writing that, remember frequency is equal to C over lambda. So C over lambda. Yes? Also on your data sheet. Okay, so what we can see from here, because we are comparing kinetic energy with wavelength. Okay, so what did I do when I got the graph? I looked at what is on my axis. Then I said, is there a formula that connects these two things? There should be. I went to my formula that is with this chapter, and I wrote it down so that I see the thing on the axis, the thing on the axis. Now I can compare the two with one another. I see this is below the fraction, this is on the top of the fraction, or on the top. So they are inversely proportional to one another. Am I seeing this on the graph? Yes, I am. They are inversely proportional to one another.
Or is the one increases the one?
Yes, if this one gets bigger, this one gets smaller. Yes? Okay, right. So now we see the graph. It makes sense according to my formula. My mind is ready. Okay, next thing they say there, use the graph to determine the maximum kinetic energy of an emitted photoelectron when the wavelength of the incident light, the light coming in, is that. So when the wavelength is 1,
12.2.
no, it's not 12, it's just before 12. Okay, so what are you going to do? You're going to say here's 1, 2, 3, 4, 5 lines. What's the difference here? 2. 2 divided by 5 gives you 0.4. So this is 10.4, 11, no, 10.8, 11.2, 11.6, 12. So the line just before it is 11.6 times 10 to the power negative 19. T 11.6 times 10 to the power negative 19 joules. 19.
Okay, so what did we do? We count the number of rocks minus
No.
the difference then divided.
Yes.
What, ma'am, can you please start with the 17.1 question?
Jy moet luister. Because I'm pressed for time. Okay. They asked for 1 times 10 to the power 17. Go up. There it is. But it's not exactly on 12. It's just below it. So there's how many lines? 1, 2, 3, 4, 5 lines. What's the difference from there to there? 2. 2 divided by 5 gives you 0.4. So this is 10. 10.4. 10.8. 11.2. 11.6. Sharp? Okay. Next one they say, what relationship between the maximum kinetic energy and the wavelength can be deduced from the graph? They are what to each other? Inversely proportional to one another. No, indirectly does not. There's no word like that in science. If you say that wrong, 0 out of 2. So you're going to say the maximum kinetic energy of emitted photon electron is inversely proportional to the wavelength of the incident light. So you're going to say the words that they say here. Maximum kinetic energy of an emitted electron is inversely proportional to the wavelength of the incident light. You give back the words that they give it to you. You're not just going to say inversely proportional. You must say what is inversely proportional to what. Okay. Next question they asked. Define the term work function in words. What is that? Energy required for an electron to be emitted from the surface of a metal or metal surface? The minimum energy required for an electron to be emitted from a metal's surface. Genigtig boekemoesel. Jy stadig. Jy moet vinniger. Or are you asleep? What are we blaming today? Okay, next one. Use the graph to calculate the work function of the metal used as a cathode in this photo cell. Alright, so we know now we're going to use this formula. What can we put into this formula? Work function is the question. Constant, constant. If I can get the wavelength here and I get the kinetic energy here, I can put it into this formula. But now, let's say use the graph. Meaning you must use points from this graph. Now be careful. Some of these points, like this one or like this one, is not exactly on the line. Can you see that? Not exactly on the line. This one, not exactly on the line. This one, also not. This one, also not. So be careful which points you choose. I think the one that is the most on the line is 1.5 or something like, where did I see that? This one. Do you see this one? Where's 14? No, it's not. Can you see this dot is in between two lines? So you can't choose this line for that. So you must look at the graph and get a dot. Where did I see this one? It's exactly on the line. And 1.5. Yeah, I'll say 1.5. It's close. Okay, so if you take another point, your answers will be different. Okay, I'm not going to do that calculation now. So you're going to choose a point on the graph and put it into this formula. Just write down this formula. Yes, you can. Just write it like no. Okay, and then I ask, yes? So, no, you have this on your data sheet, and then you have E is equal to this on your data sheet. And then you substitute that in there.
If it is the exam, you can just write this.
Yes. Okay. No. Alright, now you have to calculate the work function. Okay, so then you will have the work function there. And then they ask, calculate the maximum kinetic energy of an emitted photon electron when the wavelength is that. So let's check. The wavelength is that. It's not on our graph. So what are we going to do? We're going to put in constant, constant. We're going to put in the wavelength that they tell us. We just calculated the work function in the previous question. And then we can calculate the kinetic energy. Okay, so the same formula for the next question. Exactly the same formula. Sharp, sharp. Now you can just write down the formula because I want to go to the multiple choice question. Yo. Yes. Excuse me? We're going to go through your September question papers thoroughly. And then we're going to, if I see you guys have no idea what's going on in Newton's law, we're going to focus on that. When I see you have no idea what's going on, we're going to focus on that. Now we're going to work our butts off next time. Okay. Yes, for 2 weeks. Okay. Right. Then don't blame me if your marks aren't good at the end of the year. No, there's school. We must say farewell to you. You're going to have a day where you ring the bell. We're going to have like ceremonies for you. No, because that's not your last day of school. Okay, right. It says there, the energy level diagram for an element is shown below. I think this is in your notes. Yes? Multiple choice questions in your notes? I don't know. It should be.
This is
Okay, so maybe you didn't copy. All right, so just do it in your writing book. It will be, you know, that paper that I sent the multiple choice booklet? Yes, so just write multiple choice. I don't know. Sometimes when I send it to be printed, things get lost. Okay. The energy level diagram for an element is shown below. E0 represents the ground state. The energy change from E0 to E1 is smaller than that of E2 to E1. Okay, so let's just see. Let's say this is 0, then this is 10, then this is 50. So they say this energy is bigger than this energy. Okay, now they say the electron transition from E2 to E1 corresponds with green light. So it means if an electron jumps down or falls down, it gives off green light. In the element spectrum, the transition from 0 to E1 corresponds with what? So wait. So it goes up there. So it's not going down here. Okay, first of all, it goes up. How does it go up? If it absorbs energy. When it goes down, it releases energy, emission. When it goes up, it absorbs energy. So it must be absorb or absorb. Okay, so it can't be C and it can't be B. Then, absorption from green light or absorption from red light. This here, this change is a big energy change, and they say that is for green light. If this was also 40, then it will also be green. But it's not. It's 10. It's a smaller energy jump. So it will be red light.
So if it's the same energy,
Yeah. So, you must know your colors. Red, orange, yellow, green, blue, purple, UV. Yes. So you start with infrared and you end at UV. What does UV stand for? Ultraviolet. Violet is purple. Okay, ish. Right, it says there, a metal is illuminated, blah, 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 blah. Which one of the following graphs best illustrates the relationship between kinetic energy of emitted electrons and the frequency of the incident light? We are referring now to this formula. Yes?
yes.
We're comparing this with this. They are directly proportional to one another. So, which of these graphs shows directly proportionality?
So choose one. A, B, C, A, B, D.
Say again, which?
I was saying A, B, D.
You're saying A, B, and D.
It's like a straight line. So C is like inverse.
Okay, C is not inverse. This will be inverse proportional, but it's not C yet.
My B or D.
Okay, so B and D, I agree with you. Which one? If you look at here, when the kinetic energy is 0, when the kinetic energy is 0, is the frequency also 0? No. Then frequency is still equal to something. To the threshold frequency. Or this is the work function that is equal to the threshold frequency. So when the kinetic energy is 0, frequency is not 0. When the kinetic energy is 0, frequency still has a value. So the answer is D. Chap? So in this chapter, your graphs will always cut one of the axes. It should, because there's a starting point. Okay, next one. A line emission spectrum is formed when what? Emission does what? Is it energy released or energy absorbed? Emission. Energy released. So that means when you go from a higher to a lower energy level, because then it gives away the energy. Okay? So it goes from a higher to a lower, higher to a lower. So it's definitely not C or D. A or B. High to low what? Energy level? Emit energy or absorb energy? They emit energy. So it's A. Like? Yes. Which one of the following phenomena provides the most conclusive evidence for the wave nature of light? A. The photoelectric effect. Next one. A neon tube lights up when a large external voltage is applied across it. Okay, so neon lights, gas, and then they give you big voltage and then it lights up. Which one of the following best describes the type of spectrum absorbed when the gas inside the tube is viewed through a diffraction grating? So when you give high voltage through it and it gives off light, is it emission or absorption? Emission. If it was absorption, you would see nothing. It would be darkness. Okay, so it emits light. Let's see. Continuous, no idea. Absorption, line spectra, emission. Okay. Next one. When a clean metal plate is irradiated, there we go, with the light of sufficient energy, photoelectrons are emitted, the photoelectric effect. The intensity of the light is now increased. What is intensity again? Number of photons. That gives you the number of electrons being emitted. Number of photons, number of electrons. If they increase that, then increase the number of photoelectrons emitted per second. Yes. Or increase the kinetic energy. What will increase the kinetic energy? Okay. Now, was it bewaar jou siel? What does it say in English? You dare to get this question wrong in the exam. I will scratch your paper. Bewaar jou siel, like, you must sleep with one eye open. Be aware. Okay, I'd rather not try. Okay, which one of the following correctly represents the given type of electromagnetic radiation in order of increasing wavelength? Remember, if they increase the wavelength, it means they decrease the frequency, meaning they decrease the energy. So it means increasing wavelength. So it means it must go from a high energy to a lower energy, because you're going to go lower with your energy. Increasing wavelength, right, means you're going to go to a lower energy wave. You start with high energy, and then you're going to increase the wavelength, decrease the energy. Wavelength is inversely proportional to frequency, and frequency is directly proportional to energy. So you start from high energy, and you're going to go to low energy. Increasing wavelength means decreasing energy.
Yes.
Sinumta, what did you do in grade 10? E is equal to H times F or H times C over lambda. So if they increase the wavelength, they decrease the energy. So it means you start with a high energy and you end with a low energy wave. Okay? Which one is this? D, because you start with high energy and you're going to go to lower energy. Okay. Which one of the following best explains the formation of line emission spectra? Emission, if it is go from a high energy level to a low energy level, give off. Okay. White light passes through cold gas. It will absorb. White light passes through a triangle prism. It will just give you everything. It will give you the continuous spectrum. Okay. Electrons in the ground state move to a high energy level. Electrons are in the excited state move to a lower energy level. Yes, from excited, lower, so it gives off the energy. D. Yes. Number 9. Which one of the following electromagnetic waves have the shortest wavelength, meaning the greatest frequency, meaning the highest energy? Because wavelength is inversely proportional to frequency. Which one? Which one has the highest energy? No! Gamma rays. Gamma rays can go through lots of things and burn your body and your cells. And you can mutate. Okay. It's the highest energy one, gamma rays. Yes? Okay. Next one. When light shines on a metal plate in a photocell, electrons are emitted. The graph below shows the relationship between kinetic energy of the emitted photons and the frequency of the incoming light. So he can see nothing being released. He can see nothing being released. Here you see it starts to be released. Yes? And at D, they have a certain kinetic energy. So what will we call C there? Yes, the frequency where it will start to release. Which one of the points on the graph represents the threshold frequency? C. Okay, next one. Overexposure of sunlight causes damage to plants and crops. Okay, yes, we know that. Which one of the following types of electromagnetic radiation is responsible for this damage? Next. Radio waves does not come from the sun. Visible light does not come from the sun. There's a bit of visible light. X-rays definitely not, then we will all be vegetables. UV. Okay. Right, so grade 12s. Next class we start with electrical cells. That is actually 2 chapters in one. It's 1 chapter, but there's 2 questions in your question paper regarding this. So I see you tomorrow, I see you Wednesday, and on Thursday I see you twice, ne? Period 1 and period 5 during English.